Have you ever thought about how much memory it takes for software to handle a ton of similar things? Like when you're scrolling through a huge online catalog or playing a game with like a million trees in the background.
Yeah, that's a real challenge when it comes to building efficient systems, especially when you're trying to squeeze the most out of your resources, whether it's making sure an app runs smoothly on a phone or keeping costs down on a server farm.
Right. And that brings us to the topic of our deep dive today, the Flyweight design pattern. It's a technique developers use to cut down on memory usage when you've got a bunch of objects that are mostly the same.
Basically, it's a way to avoid redundancy.
Exactly. We've got some interesting material that breaks it down. We'll be looking at what problem it solves, how it's structured, how it's implemented, and even how it ties into other design patterns.
Sounds comprehensive. So are we going to build something with Flyweight today?
Not today. Today our goal is to understand how Flyweight works and why it matters. We'll be drawing insights from the provided sources. No coding, just pure understanding.
Great, so let's jump right in.
Okay, so first things first. What exactly is the problem that Flyweight aims to fix?
Well, one of the sources uses a really clear analogy with the travel agency. Imagine they're putting together group tours. A lot of the details are going to be identical for everyone in the group.
Right, like the hotel they're staying at, the destination, probably the breakfast they get each morning, all that's going to be the same.
Exactly, and that's all tied together with a specific package code. But then on top of that, you've got individual choices that people can make.
Like if they want dinner included or how many optional excursions they want to sign up for.
Exactly, and this is where the challenge comes in. How can the travel agency's system keep track of all this without wasting a ton of memory?
Right. You wouldn't want to store the hotel name, the destination, and the breakfast info separately for every single person in the group.
Especially when most of it's the same. It'd be super inefficient to have duplicate data like that for, hundreds or maybe even thousands of travelers.
And the source points out that in systems where you have like millions of instances, this can actually become a pretty serious problem.
Yeah, using Flyweight can shrink the memory footprint significantly, which can make a big difference. It can free up resources, maybe even cut down on costs for the company. And of course, it can make the software run a whole lot faster.
So how does Flyweight actually solve this problem?
Well, the core idea is to split up an object state into two parts. The shared stuff, which is called the intrinsic state, and the unique stuff, the extrinsic state.
So the intrinsic state would be like the hotel, the destination, the package code, all those things that are the same for everyone in the group.
And the extrinsic state would be things like dinner choice, the number of excursions, the stuff that's unique to each traveler.
And the brilliance of Flyweight is that it lets you share and reuse that intrinsic state instead of storing it over and over again for each person.
Exactly. Let's get into how it's actually structured in software. Our source breaks it down into 4 main parts.
Okay, what are they?
First up, you've got the Flyweight itself, and this is represented by an interface.
An interface.
Yeah, it basically defines the methods for both the shared and unique parts of an object.
Like a set of rules.
Exactly. It's like the blueprint for how these objects should behave. In our travel agency example, this interface is called iPatcheristic.
iPatcheristic. Got it. So what's next?
Then we have the concrete Flyweight, which is the actual class that implements that interface. This is where the permanent shared data lives.
So for the travel agency, this would be the class that actually stores things like the package code, the hotel name, the destination, right?
Exactly. It's called patcheristic, according to the source. This patcheristic object holds all the unchanging information about the trip.
Cool. Now, what about the stuff that does change, the individual preferences?
That's where the unshared concrete Flyweight comes in.
Unshared concrete Flyweight. Okay.
Yeah, it's basically just a separate class or concept that represents that unique state.
Like whether someone wants dinner or how many extra trips they're taking?
Right. In our example, that's the optionale class. So you might have one optionale object for each traveler, but they'd all share the same patcheristic object.
So the patcheristic is like the foundation, and then the optionale adds the individual details on top of that.
A nice analogy. That brings us to the 4th part, the Flyweight factory.
The Flyweight factor, what does that do?
This is the part that manages and hands out the concrete Flyweight objects. It makes sure that we're not creating new ones unnecessarily.
So in our travel agency example, if someone books the romantic getaway to Paris package, the Flyweight factory would first check if it already has a patcheristic object for that.
Right, and if it does, it just reuses that existing instance. No need to create a whole new one.
And this is where the big memory savings happen.
Exactly. The source specifically mentions that it uses a hash map to store these objects. It's a very efficient way to keep track of them.
So the pachytristic class holds the shared info, the auctionale class holds the unique stuff, and the Flyweight factory makes sure we're not duplicating any of the shared data.
Right. It's like a system for responsible sharing.
Okay, so we've talked about the structure, but how about the actual implementation? Can you walk us through that a bit?
Sure. Let's revisit the travel agency example. They get a request for, say, the Island Paradise tour package. The Flyweight factory, which is called Fabric Dépêché in this case, checks its hash map to see if it already has a pachytristic object with that specific package code.
And if it doesn't?
Then it creates a new one, stores it in the hash map using the package code as the key, and returns that new instance. This ensures that there's only one pachytristic for each unique package, no matter how many people book it.
So even if 100 people book the Island Paradise tour, there's only one pachytristic object in memory for that package.
Exactly. The shared data is only stored once, saving a lot of memory. And each person gets their own optional object to store their unique preferences.
This makes it super efficient. So we've talked a lot about the travel agency analogy. Are there other real-world examples where Flyweight comes into play?
Absolutely. One that the source mentions is video games. Imagine a game with a vast, detailed world. Think about all the objects it needs to render, like trees, buildings, characters. Many of them are going to be very similar.
Right, like you might have a forest with hundreds of trees that all use the same basic model.
Exactly. So instead of creating a separate object in memory for every single tree, the game engine can use Flyweight to share the common parts.
So the basic shape and texture of the tree would be the intrinsic state, and then the position, the size, maybe the color variations would be the extrinsic state.
And that way, you can have a forest full of trees without overloading the system's memory. The same goes for things like cars in a racing game, or even the individual bricks in a wall.
So it's about finding the commonalities and only storing them once. It's like having a master template for a tree and then just making notes about where each individual tree is located and maybe giving it a slightly different shade of green.
A perfect analogy. This concept can also be applied to things like user interfaces, where you might have lots of buttons or icons that share the same basic design.
So Flyweight can be used in all sorts of contexts to save memory and improve performance.
Right, it's a pretty versatile pattern. The source also talks about how Flyweight sometimes works together with other design patterns. Specifically, it mentions the composite pattern and the factory pattern.
Oh, interesting. Can you elaborate on that a bit?
Sure. The composite pattern is used to represent objects in a tree-like structure, where you have individual objects and groups of objects treated in a similar way.
Like a folder system on your computer.
Exactly. And the source points out that the individual objects, the ones at the very bottom of the tree, can be Flyweight objects.
Could you give us an example of that?
Imagine you're building a document editor. The characters in the text could be Flyweight objects, each representing a letter or symbol.
So instead of having a separate object for every single A or B in the document, you could just have one Flyweight object for each character.
And the composite pattern would be used to arrange those characters into words, lines, paragraphs, and the whole document. It's all about efficient organization.
So the Flyweight pattern handles the individual characters, and the composite pattern puts them all together into a cohesive document. What about the factory pattern? How does that fit in?
Well, we've already seen how a factory can be used to manage Flyweight objects with the Fabric Dépêché in the travel agency example. The factory pattern ensures that we're reusing Flyweight instances whenever possible.
It's like the gatekeeper, making sure we don't create unnecessary duplicates.
Exactly. The source provides another interesting example of Flyweight in action, managing a hotel room inventory.
Okay, how does that work?
Think about all the things that are standard in a hotel room. Towels, sheets, pillows, hangers.
Those are pretty consistent across different rooms.
Exactly, especially within the same room type. So instead of storing all those details for each individual room, you can use Flyweight to share the common parts.
So you'd have a Flyweight object for the standard inventory of a double room, for instance.
And then when you need to display info about a specific room, say room 205, you'd combine that shared inventory data with the room number and the guest's name.
That way you're not duplicating all those standard inventory details over and over again. You only store them once.
It's a really clever way to save memory and keep the system running smoothly. The key takeaway here is that the Flyweight pattern is all about recognizing what data can be shared and then structuring your code to take advantage of that. It's like finding the common denominator and then only storing it once.
So instead of having a million slightly different objects, you have a smaller set of shared objects and then just keep track of the differences.
Precisely. And that can make a huge difference, especially when you're dealing with large, complex systems. It can improve performance, reduce resource usage, and even simplify the code.
So Flyweight is not just about saving memory. It's also about making the software more efficient and maintainable overall.
Right. It's a great example of how thoughtful design can lead to big improvements. And for you, the listener, understanding Flyweight gives you a deeper understanding of how software can be optimized.
Even if you're not a programmer, this pattern illustrates a fundamental principle that can be applied in many areas of life, identifying what can be shared and reused to save time, effort, and resources.
It's about thinking smarter, not harder.
Absolutely. So for our final thought to leave you with, where else in your life could you apply this Flyweight principle? What processes or systems could benefit from this idea of sharing and reuse? It's a powerful concept that can lead to all sorts of efficiencies.
It's definitely worth pondering.
Thanks for joining us on this deep dive into the Flyweight design pattern. We hope you found it insightful and engaging.
See you next time.